Welcome to our lesson on adding and subtracting fractions. When we look at the first problem, it says 1/2 plus 1/3. Now, when we draw a picture of this, half of a cake plus a third of a cake, even if we were able to take these two pieces and push them together, we wouldn't be 100% certain how much we had because they're different sized slices. So what we need to do is make common denominators. So in other words, this could be sliced into sixths, and this pie could also be sliced into sixths. Then it would be easier for me to see that I have 1, 2, 3 sixths plus 1, 2 sixths, which would be a total of 5 out of 6 pieces. So again, what we are going to do here is we're going to make it out of sixths. The reason that I picked sixths is because 6 is the least common multiple of 2 and 3. Now, if I'm multiplying 2 to get up to 6, what I'm doing is multiplying by 3. So I'll also have to do that to the top. 1 times 3 is 3. Now here, to get from 3 to 6, I'm actually multiplying by 2, so I'm going to have to multiply my top by 2. And I get 2 sixths. Now that's represented in my picture over here, 3 sixths and 2 sixths. Okay, 3 sixths and 2 sixths, there's 3 pieces and 2 pieces, that's 5 pieces cut into slices of 6. So that's my answer, 5 sixths. All right, next question is very similar. I can't actually subtract these yet because they are different sized slices if they were cakes. So what I need to do is think about the multiples of 4 and the multiples of 3. The multiples of 4 include 4, 8, 12, 16, and so on. The multiples of 3 include 3, 6, 9, 12, 15, 18, and so on. So the smallest number that they had in common was 12. So what I'm going to do is I'm going to change their denominator to make it a 12. I'm going to keep my operation sign, my minus sign in there. And now I need to think about what I'm doing. To get from 4 up to 4 up to 12, I need to multiply by 3. And so I'm going to do that on the top as well. 3 times 3, which is 9. Now for the next part, I was at 3 and I need to get to 12. So I'm multiplying by 4 because 3 times 4 is 12. So I'm also going to need to multiply my top. So now I have 9 twelfths of a cake minus 4 twelfths of a cake. If I had 9 pieces and I take away 4, I'm left with 5. And they're still cut into sizes of 12. So 5 twelfths is my answer. All right, let's go ahead and quickly review the algorithm for adding and subtracting fractions. First step is to find the LCM, the least common multiple of the two denominators. The second step is to make equivalent fractions. That's what we had been doing here. We looked at a cake and we said, okay, well, 1/2 would be the same as calling it 3 sixths. So what we were doing is multiplying the top and the bottom by the same number. And again, the reason we did that was to get common denominators. Here I made them into sixths. Here I made them into twelfths. All right, the next step was to add or subtract the top, which is called the numerator. We're going to leave the denominator alone. We're going to leave the denominator the same. And the reason for that was because we were purposely trying to get the denominators to be the same size slice if it were pie. So we're trying to get them the same, so we're going to leave them that way. And the last step is to simplify. The only thing to note is when subtracting mixed numbers, you must make them improper. Otherwise, sometimes you will not be able to subtract, or you'll end up with the wrong number. So anytime you've got mixed numbers, it's just easier to make them improper, but for subtracting, it's required. Okay, without using any sort of diagrams or pictures, we're going to try the following, just using the math algorithm. So the first example says 11 twelfths minus 3 eighths. Now again, I need to think of the multiples. So 12 and then the next multiple is 24. And 8 also goes into 24, so that's going to be my denominator. To get from 12 to 24, I'm multiplying by 2, so I'm also going to have to do that on the top. So I did a times 2 and a times 2. So I'm starting with 22 over 24 because that's the same as 11/12. Now I'm going to convert my 3/8. So it's also going to be out of 24ths so that I can operate, so that I can subtract with it. 8 times 3 is 24, so I'm also going to have to multiply the top by 3. 3 times 3 is 9. So my problem reads 22 24ths minus 9 24ths. So my total here is 13 24ths. These don't have any common multiples, so I can't reduce or simplify. Okay, next question. 4/5 plus 5/8. The least common multiple here is 40, so I'm going to go ahead and write out my denominator. 5 times 8 is 40, so I'm going to also have to multiply my top number by 8 to be fair. So it'd be 32 out of 40. And then this side I'm going to multiply by 5 because 8 times 5 is 40. 5 times 5 is 25. So right now I have 32 40ths plus 25 40ths, which is 57 40ths. Now that looks really strange. The top is larger than the bottom. That's called an improper fraction. 40 goes into 57 one time, so that means 1 whole pie, and then there would be 17 left over, so 17 40ths. And that's my final answer. All right, now down here, I mentioned before that sometimes it's just easier to make these into improper fractions and then add. You don't have to for adding, but I like to usually. I'll do it without making them improper just to show you. But this would be 2 6/10 plus 1 7/10. And so what we're going to do first is we're going to add the whole numbers. So that'd be 3, and then we're going to add the fractions, 6 plus 7, which is 13. Now remember, we purposely put these as tenths, so we're going to keep it that way. Now the reason I was saying earlier that it's easier sometimes to leave it as an improper fraction is because you get situations like this, where now I have a whole number and an improper fraction. This improper fraction would become 1 3/10, but I already had 3. So my final answer here is 4 3/10. Now, if I had done it the first time, improper, I would have made this 2 times 5, which is 10, plus 3, which is 13 fifths, plus 1 times 10, which is 10, plus 7, which is 17 tenths. My next step, I'll switch colors so that you can see this better. My next step would have been to make them common denominators. 26 tenths plus 17 tenths. And I would have gotten 43 tenths, which still reduces to my same answer of 4 3/10. All right, in my next example, I'm going to be required to use improper fractions. Here's why. I'm not going to be able to subtract 1/2 minus 3/4. So I just need to go ahead and make them improper, and you'll do this every time you have mixed numbers with subtraction. 3 times 2 is 6, plus 1 is 7 halves, minus 1 times 4 is 4, plus 3 is 7/4. Now, the next thing I'm going to need to do is make common denominators. So I'm going to pick fourths. That would be 14/4 minus 7/4, which equals 7/4. Again, that's an improper, so I'd like to make it a mixed number, which is 1 3/4. All right, thank you for watching. Have a good day.